Welcome, Matt Taylor here with another methods tutorial. Today I'll be doing exercise 1.5, questions 1 through 3, how to do it and worked solutions. So, question 1 asks, sketch the following graphs and state the domain and range. So, A is f of x equals 1 over x take 2 plus 3. So, you should know about the transformations of these graphs. All that x take 2 does is move it 2 units to the right, just like in other sorts of graphs, and plus 3 moves it up 3. So that's pretty straightforward. This is a graph of 1 on x, just for the reference one, and then with the transformations it's going to move this way and up. This is negative, so that's just how showing you how it sort of flips when you make it negative, just in case you didn't know. But yeah, this is the graph that the question asks, and it's basically just moving the graph up 3 and across 2, changing the asymptotes, and this is here just to compare it, how it moves. Question asks the domain and range. The domain is going to be all of the x values except for 2 because there's an asymptote there, and the range will be all values except for 3 again because there's an asymptote. I'll go down to D now. D is negative 2 over 5 take 3x take 1. So this one's a bit trickier because it's got a dilation factor and it's not written the same way these are as like x take 2, sort of like this one. But what you need to do is you make 5 take 3x equals 0 to solve the x asymptote, just like you did with this. Like, you may not have thought that you made it equal 0 because it's so simple. Like, you see x take 2 and you just immediately think that it's moved 2 units to the right, but what you've done is x take 2 equals 0, then x equals 2. So 5 take 3x equals 0, and then you have to rearrange that. So you get 5 on 3, and then that is the asymptote on the x-axis, I should say. And because there's a 2 on top, it means it's dilated by a factor of 2. And that's what the graph looks like. If you charted a graph trace to that point, I should say, it would be 5 on 3, which is, I don't know, like 1.1 2/3, so 1.67. And the take 1 brings it down. And because there's a negative, because the equation has negative out here and a negative in there, the double negatives cancel out, so it becomes a positive graph. Otherwise it would be going down this way and like that. Question 2 basically follows off the same stuff, so I'm not going to draw any of those, but it's basically asking the same question, except for those you don't have to state the domain and range. You just have to say what the transformations were. So this one was dilated by a factor of 4. It was translated 3 units to the right and 2 units up, stuff like that. But I didn't even answer the question for 1D. I should do that now. The domain is all the x values except for 5 on 3, because it goes everything across. There's an asymptote at 5 on 3. Never mind that. Range is all the values except for -1, because there's an asymptote there again, just like the last question. So yep, 2 is pretty straightforward. Question 3, I'm going to just skip straight to the hardest question, 3i. So 2x squared plus 3x over 2x. 2 squared, I should say. X squared, I should say. Sorry. Sketch the following graph, state the domain and range. So it's the same, asking the same thing as 1, but they're putting x squared on the bottom, which basically just gets all the negative values and makes them positive and makes the graph steeper overall. So that's a 1 on x squared graph because there are no negative values for y, because all of them are going to be positive, and there's no value for 0. So this is the equation, and you have to simplify it by dividing top terms by x squared. So what I've done here is I've separated it because this is exactly the same as that. Doesn't really matter, that's just the same. So 2x squared divided by x squared is just going to leave the -2 by itself, and 3 divided by x squared gives you 3 on x squared, and that's where you can write your equation, because now this is in the same form as the previous questions. So dilated by a factor of 3, it's just a regular x squared. So there's no x transformations, the x asymptote is still going to be at 0, and -2 brings the graph down to. So this is the graph here. Domain and range. Domain is going to be all the real values except for 0, and the range is going to be all the values greater than -2, except for it won't include -2 because asymptote and will never reach there. So that's how to do questions 1, 2, and 3. Thanks for watching, and see you in another video.